Okay, hello and welcome back. In section 4.2, we get to work with reduction of order. So the idea is we already have one solution to a differential equation. Goal is we want to find another solution. And there's going to be two methods that we learn in this. The reduction of variables and later formula. So we'll start with y double prime minus 5y prime minus 50 times y is equal to 0. And suppose we already know y1 is e to the 10x, and we want to basically find y2. Now, in our general solution, the various possible solutions that are represented in there should be linearly independent. So we can let y2 of x equal u of x times y1 of x. You'll usually see me shorten that to y2 as u y1. So for this problem, that's equal to e to the 10x times u. So y2 prime, for this one, we would use a product rule on that. So 10e to the 10x times keep the u plus keep the e to the 10x and differentiate u. That'll give us a u prime. Now y2 double prime, two more product rules. So derivative of the first 100 e to the 10x, keep the second u, plus now I'm keeping the 10e to the 10x and differentiating u. That's just a u prime. Then I move on to the second two terms, and I'm doing product rule there as well. Derivative of e to the 10x is 10e to the 10x. And I would multiply by keeping the u prime where it is. Plus, because it's product rule, now I keep the e to the 10x and differentiate u prime. So that's u double prime on the end there. So notice we do have a couple like terms in the middle here. So we can also call y2 double prime here 100 e to the 10x u plus 20 e to the 10x u prime plus e to the 10x u double prime. So now we're going to do a little bit of substitution. We just plug this into the original and see what shakes out. So y double prime, that's going to be this guy. So 100 e to the 10x times u plus 20 e to the 10x u prime plus e to the 10x u double prime. And then we have minus 5 times u prime, or y prime, sorry. So our y2 prime is this guy. So minus 5 times the 10e to the 10x u plus e to the 10x u prime. Then minus 50 times y. I'm writing entirely too large to fit that on the same line, so I'm just going to have to ask you to use your imagination and pretend my paper is big enough for that. So minus 50 by y2 by itself, so that would be our e to the 10x by u, and we're equal to 0. So we do get a little bit of cancellation here. We've got 100 e to the 10xu, and then we have minus, distributing this, minus 50 e to the 10xu, and then we have a plus 50 e to the 10xu. Those are all gone. So then we have, let's see, we have 20 e to the 10x u prime plus e to the 10x u double prime minus 5e to the 10x u prime. So we're distributing that 5 and we're equal to 0. We've got a couple other like terms there. We have a couple things that have e to the 10x and u prime attached. So I can even factor this e to the 10x and call this u double prime, and then plus 15u prime is equal to 0. Well, I know that e to the 10x cannot equal 0. So then it's got to be our u double prime plus 15u prime. That's our 0. Now this looks kind of like a basic linear of dy dx plus p of x times y equals 0, but we have double primes instead of single here. So we just do a temporary replacement. Let w equal u prime. W prime then would be u double prime, and we do have that format then. So w prime plus 15w is equal to 0. So we have an integrating factor, e to the